All right, good day everybody and welcome once again to Justified series. And today we are going to be taking on physics, and the topic for today is simple machines. So you get, this is a very common topic in Jamb. It comes out every year, and the particular topic that comes out under it every year is what we call the pulley system. So as a science student, you need to master what I call simple machines and then pulley system. But then let's go straight to it. Before we begin, my name is Justified. I am the CEO of Justified TUTOR'S Academy, and you're welcome to Justified series. So yes, let's begin. Let me wipe this off. So the first thing we have to know under simple machines is its definition. So now, what is the definition for machine? This one is very simple, but I'll read it from my book. Now, a machine is any device that makes work easier, either by multiplying force, changing the direction of force, or increasing speed or distance of of motion. So that is the definition for for a machine. I get me? That is the definition for a machine. Why a simple machine is a basic mechanical device with few or no moving parts that makes work easier by changing the direction of or magnitude of a force. So all these two definitions, you have to know them. But then that's not all. We have what we call basic terms that are used in simple machines. And the first one I have here in my book is effort. Now, what is effort? Effort is the force applied to operate a machine. So, and then the next basic term under simple machine is is load. So you get, and load is the resistance. Load is the resistance or weight. So you get, load is the resistance or weight the machine is trying to move. So you get, so the machine is applying force to move a particular resistance or weight. So you get, so these are the two things that you need to know very, very well in under simple machines. And we also have more basic terms. We have C, which is the fulcrum. So you get the fulcrum, and then the fulcrum slash pivot point. So you get, so this one is load. I beg, let me put it there, equals to load. This one is load, right? Yes, this is load. So fulcrum slash pivot point is a fixed point about which a machine turns. So you get, that is the definition for fulcrum. And then the other one is we have the distance moved by the effort, and that is how far the effort moves. The other one is the distance moved by the load, and that one is how far the load moves. So those are the five basic terms of simple machines. But then we have some things that you need to take note of. Also, there are also basic terms in simple machines. So I need you guys to write them down right now. And the first one under this section is the mechanical advantage and the velocity ratio, right? So these two things are the key terms that you're using very, very in simple machines. Now write this down. What is mechanical advantage? Now, mechanical advantage is how much a machine multiplies force. That is mechanical advantage. And then the formula for mechanical advantage is given as load over effort. Do you get it? That's the formula for mechanical advantage, load over effort. And then okay, let me just go to velocity ratio first. And for velocity ratio is the ratio of distance moved by effort to the distance moved by load. So you get the ratio of distance moved by effort over distance moved by load. So therefore the formula for velocity ratio is is distance moved by effort over distance moved by load. You get, you need to pay attention to what these things when you are giving your question. You get, but then there is one thing I need you guys to what to note. For mechanical advantage, now when your MA is greater than 1, listen though, when your MA is greater than 1, what does it mean? It means that what the machine we built will make work easier. But then when your MA is equal to 1, it means that what there is what no advantage. And when your MA is what is less than 1, right? When your MA is less than 1, machine will have to increase its speed, and what we have to increase its speed or distance instead. So these are the key things I want you guys to know as well. So now let's just move straight into what into the efficiency of what of a machine. So yes, the formula for efficiency of machine. Oh, before we go there, let's take the definition for efficiency of a machine. Now, efficiency of a machine shows how effective a machine is, and the formula for what efficiency is given as what mechanical advantage over what the velocity ratio. I remember I told you that was the formula. Sorry, it's meant to be times 100%. Yes, multiplied by what 100. I remember I told you that what mechanical advantage is what is load over effort, right? So we're having what load over effort here divided by what velocity ratio, which is what distance moved by effort over what distance moved by what by the load. So you get now everything in brackets multiplied by what 100%. So you get, so breaking this one down now, you have what will be left with what load over effort. If you are turning division to multiplication, this one will go up, this one will come down. So you get to be having what times distance moved by the load over what distance moved by effort multiplied by what 100%. So this now will be our formula for efficiency whenever we're not giving what our ME and VRO. So you get so this is just going to be the what the derivation of what of it. Now, one thing I need you guys to notice this is that efficiency is never 100% because of friction. She gets efficiency is never 100% because of friction. She gets the so, and also note this: the closer a machine is to 100%, the better that machine is. Do you get it now? So yes, I need you guys to write that down. All right, so that is that on the formula for machines. I hope you've gotten them down now. We'll be using it in the future. So you get when we are practicing questions. All right, so now let's now take some definitions here again. Yes, because of we're now moving towards two types of machines. So you get, and then the first one we have here is what is, let me clean this basic term and turn it to types of machine. So quickly, all right, so we're now dealing with what with types of machines, right? Or we can say simple, sorry, I've already put CHIN, yes. We can say simple machine. So the first type we have here is our lever. And I believe in our secondary school, we've all learned what a lever is, right? So now, again, write this down. A lever is a right bar that turns around a what? A pivot. And then we have three classes of lever. We have the first class, the second class lever, and then the third class lever. She gets. Now the first class lever always have its fulcrum at the middle. So how do I do it now? Let me put it here like this. So the first class lever always has what is fulcrum at the middle. She gets now at the middle. So I'll just detect them. You just write it down. She gets. So the first class lever always has what is fulcrum at the middle. The second class lever has its load in the middle. She gets. And then the third class lever has its what? Its effort in the middle. That is the best way to what? To identify them. And then quick example of a first class lever. I would advise you go and do your research on more. Sure you get. But the ones I have here are what? Examples of a first class lever is what? Seesaw, scissors, and then what? Pliers. Are you getting me? First class lever examples are what? Seesaw. Seesaw is spelled S-E-A-S-A-W. Am I right? Sorry, there's no A here. This is it here. This is spelling here. Seesaw. Exactly. Then scissors. Your normal scissors. S-C-I-S-O-O-R-S. That is it. So seesaw, scissors, and what? And pliers. So those are the what? The examples, or some examples of what? Of first class lever. Ensure to do your what? Your research on the others. And then for second class lever, we have what? Wheelbarrow, nutcracker, etc. Find the others. And then for third class lever, we have what? The human arm, the tweezers, and then the fishing rod. Do your research on the others. So the next one we now have here for types of what? Of machines, we now have what? The pulley system. Yes, we have the pulley. Yes, this is key. We have the what? The pulley. All right, so now under the pulley, the definition of a pulley is that what? A pulley is a wheel with a rope to lift loads. Yes, a pulley is a what? Is a wheel. So you get a wheel like this with what? With ropes around it. So you get to what? To lift loads. That is what a pulley is. So you get, and then we have types of pulley. We have the number one, the fixed pulley system, the movable pulley, and then what? The block and tackle what? Types of pulley. So you get. Then under this again, types of machines, we have what we call what? The inclined plane. This one also comes out the Jamb every year. Inclined plane, and by the grace of God, we will touch it as well. So the inclined plane now, an inclined plane is a slanted surface used to what? To raise objects. I get me. And then examples of these are what? Ramp, staircase, and slides. I get me. Then the next one is what? The wheel and axle. The next one is what? The screw, and the next one is what? Is wedge. All of these things I've listed are what? Are types of what? Of machines. So I'm trying to rush so I can quickly get into what? Solving question. So okay, I guess that is that on all of these parts. So let's move straight into what? Into our first question for today. All right, stay with me guys, and then follow me very, very, very carefully. All right, let me rub this part. So let's take our first example, and it's gonna be a jump pass question. So stay with me guys. All right, so guys, I'm now going straight into what? Into the Jamb series book I sent to you guys. You can check it out in the drive. You see the Jamb series book, and then check out chapter 9. You see simple machines there. So I'm starting with what? It's question 1. Follow me. Question 1. So question 1 says, which of the following statements defines correctly the efficiency of a machine? Which of the following statements defines correctly what? The efficiency of a machine? Is it A, the load carried by the machine divided by the effort required in carrying the load? Is it B, the distance moved by the load divided by the distance moved by the effort? Is it C, useful work done by the machine divided by the total work put into it? Or is it D? Now, the answer to this question is what? Is C. And I will tell you why. The answer is C. Number 1 is C. Let me put it there. Now, efficiency. Remember, I told you that what? That formula I gave you guys. I said that what? Load times what? Times distance moved by load, right? Over effort times what? Distance moved by effort times 100, right? This was the formula I derived for you guys after breaking down the efficiency stuff from MA to VR to the. You get what I get? I get me. So now, when you multiply load by distance moved by what? By the load. Are you getting me? This statement simply means that what? A useful work has been done. She gets. So we call this the useful work output, which is the load times distance by load, and then we call this what the useful work inputs. Yes, the useful work inputs. Total work inputs rather. Sorry, she gets. So that is it. So do not mistake it. She gets. So this is the formula, and then the answer is what is C. Are you getting me? So let's now move to question number 2. It says an inclined plane of theta acting as a simple machine has a velocity ratio of what? Of the answer is what? The answer is 1 over sine theta, which is what? Which is B. She gets. So question 2 is what? Is B. Now you might be wondering, how did I know it's B? Let me quickly just do something for you guys. She gets. Let me quickly dictate for you guys velocity ratio formula she gets for all machines. Yeah, so that can be easy for you guys to memorize and then know in the examination. So very quickly, let me write it here. So yes, velocity ratio formula for all machines, which is number 1, we have the lever. She gets. 1 is the lever, and then it is equal to what? The lever one is equal to what? Is equal to length of what? Of effort arm over what? Length of load arm. She gets. So length of what? Effort arm over length of what? Of load arm. That is the formula. The second one is what? Is the wheel and axle, which is what? Radius of the wheel. She gets. So number 2 is the wheel, and then what? Axle, which is what? The radius of wheel over what? Radius of axle. Number 3 is what? Is for pulley system. The velocity ratio for what? For pulley system, I'll call this what? PS is equal to what? Is equal to the number of ropes. She gets. The number of ropes. The number of rope strands. Yes. So the number of ropes, that is this one. The number of ropes in a pulley system, all these things here are what? Are the velocity ratio for a pulley system. She gets. So that is that. Don't worry, when we get there, I'll explain better. Moving on now, we now have what? For the inclined plane now. The one that brought us to this part. For the inclined plane, the velocity ratio for an inclined plane is given as what? The length of slope over the height, which is also what's written as what? 1 over sine theta. Now, when you've crammed all these things in your head, or I say crammed, when you've actually memorized all this in your head, you can actually easily know their velocity ratio whenever they ask you to get in the examination. But we're not done. The last one here is what? Is the screw jack. The screw jack here is what? Is 2 pi L over P. This is the formula for what? For the velocity ratio of a screw jack. She gets. So now, please also write this down very quickly. Key characteristics of what? Of simple machines are these. The unit of what? Of the VRU is what? Is unitless. I get me. That is, the velocity ratio does not have any units at all. She gets. And then what? Friction. VRU is independent of friction. She gets. That is it. And then also, an ideal machine is always what? 100% efficient. All right, guys. So that is it. So yes, let's now move on back to what? Our questions. The question we're practicing. So question 2 is what? Is B, 1 over sine theta. Now for question 3, you now say, which of the following machines does not apply the lever principle? Which of the following machines don't apply the lever principle? Now, once you've which of them? The answer is clearly written there, is C, which is what? The single moving pulley. Because of what? The single moving pulley is not under lever at all. It is what? Under, so question 3 is C. Question 4 now. Because of this one, single pulley system is what? Under what? The pulley system and not the lever system. She gets. All others are part of what? Of, or are under levers and not under, are under levers. Only that one that is what? Not under lever. So question 4 now says, a machine has a VRU of 5. It requires what? 50 kilogram weight to overcome what? A 200 kilogram weight. What is the efficiency? So let me rub this off because I'll be solving question 4 here. So now we have to find efficiency, right? And efficiency is what? Is MA over what? Over VRO times what? 100. Now we are already given what? Our VRO to be what? To be 5. Are you getting me? Yes. Our VRO right now is 5, and then we are told to what? To find our efficiency. What is left for us was to find our MA. And remember, I told you that what? Our MA is equal to what? Load over effort, right? So now in the question, we are now told that a machine of VRO 5 requires 50 kilogram weight. A 50 kilogram weight. That means it needs. That means the effort they'll be putting in is what? Is 50 kilogram. Yes. The effort they're putting in to overcome 200 kilogram is 50. So therefore, we are overcoming 200. That is the load. She gets by what? 50, by adding an effort of 50. Now, when we divide this, we will get what? 0 cancel 0, 5 cancel 5. Yeah, we have 4. Because of 5 times 4 is what? Is 20. So our mechanical advantage is what? Is 4. So now for the efficiency, we have what? Efficiency is equal to what? Is equal to 4 over, yes, over 5 times 100. Now, when you punch this inside your calculator, you should be having 5 years what? Or don't you calculate, just here. 5 years what is 1, 5 years what is 2, right? So 2 times 4 is what? Is 8. 8 times 8 plus 10 is what? Is 80. So therefore, the machine is what? Is 80% efficient. So therefore, our correct answer is what? Is E, 80%. All right. I guess you guys are following me well. You can see the way I'm doing my calculations. It be like magic, Abi. It's not magical. It's just simple mathematics. Learn how to what? Always divide everything in between. Sure you get. All right. So now question 5, which is the next one. Question 5. So that is that on this one. Now question 5 says a plane inclined at an angle of 30 degrees to the horizontal has an efficiency of what? Of 60%. Okay, the first parallel to the plane required to push a load of 120 Newton uniformly up the plane is what? Is dash. So we are now dealing with what? With inclined plane. And remember, we are told to what? Find they said you find what? The force. They said the first parallel to the plane required to push the load up. She gets is what? So we have to find the efforts that will be required to push the load up. She gets. So now remember the formula for efficiency. MA right over VR. And then yeah, we are not given our VRO. So we still have to find our VRO. She gets, and our VRO for inclined plane is equal to what? 1 over sine 30 degrees. She gets, Abi? Yes, 1 over sine 30, right? Hey. Sorry, 1 over sine theta. Why am I saying sine 30? The formula for VR is what? Is 1 over sine theta. She gets. But then, in the question, we were told that what? That a plane inclined at an angle of what? Of 30 degrees. So that is why what? We are having a 30 degree here. So to find our VRO now, our VRO will be what? Will be 1 over sine 30. That is it. Are you getting me? And then sine 30 is what? Is 0.5. So sine 30 is what? Is 1 over 0.5. So 1 over 0.5 is what? Is 2. In case you don't know, is 2. I beg. No, all these simple things are basic. 1 over what? 0.5 is what? Is 2. So that is that on our VRO. So I will clean this off and write our VRO here. So follow me carefully. So our VRO what? Is equal to what? Is equal to 2. Now, the next thing we have to do now is what? Is, since we have our VRO and then we have our what? Efficiency. The next thing now is to now what? Find our what? Our mechanical advantage. So we can use that mechanical advantage to now find what? Our effort, because of we already have our load. Okay, now there is one thing I skipped. Please, anytime you are doing a physics question, always write out all that you are given so that you can know what to do after each step. Sure you get. So that is it. So now that I've gotten our VRO as 2, let's now find out what our mechanical advantage. Remember, our efficiency is equal to what? 60%. Yes, 60%. So what do we do right now? We now find our MA. Let me clean this one now. So we'll be doing like this. 60 over 100 equals to what? MA is what? Is TMA over 2. 60 here, 1, 0. She gets cancel it. So 2 here is what? 1. 2 here is what? Is 3. We're having 3 over 10, right? So therefore, our MA, Abi, wait a sec. Let's rewind small. Let's rewind. Let me draw it again. I beg, I don't want to make mistake. All right, so let's go again. So my hand is paining me. So let's go again. So we're having 60 here, right? 60%, which is also known as what? 0.6 exactly. 60% is also known as what? 0.6, and we're having our MA here, and then we're having it over 2. So 2 times 0.6 will give us what? Will give us 1.2, which is what? MA. So our MA now is what? Is now equals to what? 1.2. So that is it. Our MA is equal to 1.2. So I beg, don't go and be doing mathematics. Just know how to multiply before you go and hang. So yes, that is it, guys. So so now our MA is what? So we've gotten our VRO as 2, MA as what? 1.2. Now the next thing we now do is what? Is now find our what? Our efforts. Given that our MA formula is what? Is load over effort. Now our load in the question was given as what? As 120 Newton. So right now we'll be having 1.2 is equal to what? 120 Newton over the effort. Make your effort the sum of the formula. We have what? Effort is equal to what? 120 over 1.2, which is equal to what? 1.2 in 120 give us what? We give us 100 Newton. You see, it's simple as what? As ABC. That is on inclined plane. So we've done one on what? Normal efficiency, and then one on inclined plane. Now question 6 is on what? Is on the pulley system. I hope I can explain this one very, very well in this class. So you get, but then just follow me carefully. Now, this one says the figure, you see the image on your screen. Yes. The figure here represents a block and tackle pulley system on which an effort of W Newton supports a load of 120 Newton. If the efficiency of the machine is what? Is 40%, then the value of W is what? Is dash. So now this one, I need it what? To calm down and listen carefully. Listen carefully. Because of this question 6. Okay, so question 5 is what? Question 5 is B. So now question 6 is what we are pending now. You get question 6, you guys open your ear and then learn. You open them down. So yes, now question 6, you have to write out what you are given. You get, you need to write out what you are given. They said that what? We have a load of what? Of 120 Newton, and then we have our efficiency to be what? To be 40%. They said we should find our what? Our effort, right? Let me write this one as like this. Yes, effort. So we should find our effort, Abi. So we are looking for the effort, right? We are looking for the effort. So now let me now tell you the trick. This is a pulley system type of question. So we're using what? The formula for what? For pulley system. So yes, now let me tell you the trick now. To find our what? Our effort, we need to what? First of all, find what? The mechanical advantage, because you can only find efforts in what? In mechanical advantage, because of the formula for what? MA is what? Is load over effort, right? So that is it. But then to find out what our MA, we have to what? Make use of what? The formula for what? Efficiency. So now efficiency formula is what? Equal to what? MA over what? VRO. Now here is the tricky part. We are not giving VRO. Sure you get? We are not giving VRO, but in the question, it is very, very what? Easy to what? Find VRO, because of when you are dealing with what? With a pulley system, the velocity ratio of a pulley system is what? Is the number, let me go back there, is what? Is the number of what? Of rope strands. Remember I told you then, That's why you guys write them down where she gets the number of rope strands. So let me just try to draw it the best way I can, because I can see something like this here. Yes, this is where it is, right? Then we have something like this going down from it. Yes, then we have 120 here. Then we have a circle around here. Yes, that drops down here. We now have what? Hope I tried, Sha. We now have the W Newton here. She gets. So this is the load. Sorry, this is the effort. This is the load. I get me. So then we now have the strands. She gets that goes like this. We have the first one. We have the second one. We have the third one. We have the fourth one. We have the fifth one, and down to the sixth. Yes, that's what it was. So in the image, we had about 6 strands in the velocity ratio. But normally, what you do is that what you will count all the strands from here. For me, like this, you count like 1, 2, 3, 4, 5, 6 until you get to the middle. You can also count from top too as well. She gets once you get to the middle. That's what you are basically meant to do. You're meant to count the number of strands she gets inside. Yes, so that is basically how you do it. So that will give you what the velocity ratio. So when you count it now, you will get 6 strands. You can don't worry, you can go practice more questions. If you see on one line, if you are doubting me, so our VR becomes what? Becomes 6, right? So now that we have our VR to be what? To be 6. Now that we have our VR as 6, now we can now proceed to what? To solving the question. Yes. So our efficiency 40% is also the same as what? As 0.4. So now in the question we have what? 0.4 equals to what? MA over what? Over 6. 6 times 0.4 is what? 6 times 0.4. Let me quickly punch my calculator. I don't want to waste time again. 6 times what? 0.4 is 2.4. So our MA is what? Is 2.4. Right? So now 2.4 now. We now have to what? Make use of what? The MA formula, which is what? Load over effort. So now MA is equals to what? Load over effort. Whereby our MA is what? Our MA, let me clean this one, comma. Our MA is what? Is 2.4, which is equal to what? Our load is what? Is 120 over the effort. So effort now equals to what? To 120 over 2.4. And 120 divided by what? 2.4 is 50 Newton. And that is the correct answer. Let me see. Let me check the answer in this book. Question 6. Right. Question 6. Yes. Question 6 is what? Is 50 Newton. And that is what? Option C. All right. So now we've come to the end of what? Of today's video. Yes. Just 6 questions. Or let's see question 7. Hey, no, come on. Let me see if I can do question 7 right now, because I want to make this video short so that you guys can learn it well. Oh boy. Okay, let me see question 7. Okay, let's take question 7. Let's move on, Jerry. Let's party on. Let's ride on. So let's take question 7. Question 7. So question 7 says the mechanical advantage of an inclined plane depends on A, its length, its height, the product of its length and height, the ratio of its length and height. What is the correct answer? Now, the correct answer is what? Is option, what is option D? Yes. The mechanical advantage depends on the ratio of its length and height. All these things you need to know them. These are the areas that what Jamb usually asks questions from. So question 7 is what? Is D. All right, so we are going to be stopping at question number 7. So in more class, I want to actually touch what? More questions on the pulley system, because of that pulley system is what I've seen that comes out in Jamb. I'm going to be touching different kinds of questions on it. She gets, including with the one that has to do with what? Equilibrium. She gets the one that has to do with what? With block and tackle system a lot. I will touch that one as well. Then we can still touch a couple more questions on what? On other simple machines. But this one is the one for today. And I hope you enjoyed this video. This video should drop on Saturday. If it not drop, then it means that, well, don't worry, to drop us out today by grace of God. So guys, thank you so much, and I love you guys. Ensure to practice more questions. I've already sent I've sent this material to you guys, like I give to everybody. Normally this material is meant to be for what, only people that paid for What's Me plan, but I said no, let me give it to every other person. She gets, that is it. So you guys should go there and practice more questions. There are about, how many questions here? Let me see. There are about 44 questions on simple machines in this part. She gets, and then there are also questions on other topics as well. So ensure to practice as many questions as possible. And if you have questions, please ask your question in the secret group chat. All right, guys, I remain justified, and I'll see you guys in my next video. Ensure to read well, eat well, and sleep well. Bye for now.